Hello everyone, and I hope you're all doing great today. Today I just wanted to share this little fun card with you. This is the Mandelbrot set, and I'm going. What I'm going to share with you today is just a simple code that you can use to produce this graph. It's cool, right? Actually, you like it pretty much. So, yeah, as I just said, I'm going to share my code. Actually, we're not going to code in this video. The code is ready for you already. So I'll give you the link to download the project from GitHub, and maybe maybe you will use the same code, but you can also decide to write it on your own, and just let me know how it went in the comment section. So let's jump into the course object here. The Mandelbrot set is, well, it's just a set of complex numbers. So given the complex ensemble, the Mandelbrot set is just a set of complex numbers satisfying this equation, and I think that's the most important information we need to start coding, right? Okay, so the next step is the code. Yeah, let me explain briefly which is what is what, which is which, who is who. Yeah. So to start the set of the complex number sets, so I need to define this entire domain or area, and to do that I will have to define the margin. So you need the boundaries for the x-axis and the boundaries from the y-axis, and it defines the complex space, this space. Then you will have to again, in this code I'm representing a complex number by the real part and the imaginary part. This is why you will see that I have two arrays or two vectors to represent, one of them to represent the real part and the other one to represent the imaginary part of that complex number. And this is where I define the point within the space. So I need a set of let's say n starting points, and it's supposed to be the entire space, not only the black dot or maybe the black graph. The entire space is the starting ensemble. Then after that I will run the you need a main loop. So let's jump back into this file. So each point from this space, normally to belong to the Mandelbrot set, should satisfy this equation. It means that for a given complex number c, I will run a certain number of iteration to test this equation, and if at the end this equation is always satisfied, I will then upload this point into the Mandelbrot set. This is how the thing is supposed to run. Okay, so to check the condition, I need this variable, which is a bool, and Again, this is because we are checking something. We need to know if a statement is true or not. So the condition is satisfied if the real part will belong to this interval. So from -2 to 2, and the imaginary part will belong to this interval from -1 to 1. And you will have to run in this code. I'm running the check 100 times to make sure that I've done it enough to say the value in C belongs to the Mandelbrot set. So then, if the condition is satisfied, you will just add the value you're checking into the Mandelbrot set, and the Mandelbrot set again is just a vector. Let's say vector, or yeah, here I'm using Q vector, but if you're using the standard C++, for example C++11, you can use a simple std vector to do the same thing. It will work because I think I have a code doing the same but with that standard. Maybe we can check here. Anyway, no, let's check. Yeah, it's here, and let's see. Yeah, so definitely you can use a std vector and it will also work. All right, so yeah, so after that, if you have introduced the new point into the Mandelbrot set, you will just have to move to another point in the entire space. And when the code or the loop will cover all the space, you will just plot the Mandelbrot space. Yeah, it's redundant, but I think you get the point. Yeah, and the rest of the code is just to repeat the same thing but with different assumptions. So let's run and see how it looks. You will have to define, oh yeah, this is something cool. Actually, you can combine the console application and with the console application with the GUI, and actually I think it's cool for me. So let's define the lowest value of the real part of C, and then the greatest or the highest possible real part of C. Then the same thing with the imaginary part, and then this one is to define the resolution of your plot. So how do you want something coarser, or do you want the finest possible? My advice, try with something coarse enough in the beginning to make sure that your code is right. Then maybe after that you can decide to give more resolution into your graph, because if you try something with a high resolution at the beginning, maybe you will wait a long time for nothing. So let's say 100 and 100. This is already enough, but you see the time it's taking to display. Oh yeah, cool. You see, so this is the entire complex space in red, and then I have my Mandelbrot set in blue, and you can see that it's pretty close to this one. This is because I'm not using lines to display the sets. I'm using dots, so this is why we don't have the exact the exact output. But I think yeah, definitely, as you can see. So this is one resolution, and you have something more like with a better resolution than the best in this case. This is the best resolution in this case, and it looks nice for me, actually. So yeah, try this and let me know how it went on your side, and maybe you can try with your own language, or I don't know, or what coding you're using, or what style you're using. I don't know what tool you're using to display the graphs. Just try with your own product and let me know how it went on your side in the comment section. See you.